Welcome back to Made in Japan, where I show you how I make things while living overseas. It's been a while since I made the video on my home lab, where I showed everyone how to create a Proxmox server with 2 VMs, one that hosts my data with TrueNAS, and the other a Docker Ubuntu server. I showed everyone my containers and the settings for my media setup, and hinted at game servers, but ran out of time. So I wanted to go more into details on why I like Docker, and how easy it is for anyone to set up game servers like Valheim, Enshrouded, SpaceEngineers, Minecraft, and Palworld. If you're a fan of my home lab content, let me know by hitting that like and subscribe button. Also, feel free to leave questions and requests in the comments below. I recently attempted a hardware modification on my server, and it didn't go too well. So after a new motherboard and a reinstall, using my own video as a guide, I got my backup and media servers back up and running. I like using Docker with Portainer to handle all of my containers for my media content and game servers. You could start up the normal software servers on your gaming computer, but there are many downsides to that. Whether you want to save some money on electricity and shut down your super powerful gaming rig at night, or another CloudStrike incident happens and you're forced to shut down your computer, those game servers will go along with it. Now, it's not such a big deal, but you do have to go through the process of starting up each of your servers again manually. And there's extra windows all over your screen. Some of them you can't even close or minimize, ruining your beautiful desktop setup. On the other hand, Docker runs in the background and starts when your PC does, so you don't even have to think about starting up your Minecraft server after a reboot. And it's even better if your server is a whole different computer. I have a friend that used my last video to set up his server on an old Lenovo laptop he had kicking around. Another good reason to have a separate server is you don't want your game servers taking up your precious resources. Your gaming PC is meant for gaming at the highest frame rates and with beautiful, buttery smooth graphics. You don't want memory or CPU resources taken up to run servers that you personally might not be using, but your friends are. Most containers are built to take the minimum resources and can easily work on any hardware, from a rack mount server to an old Lenovo laptop like my friend. Another great reason to run containers is if you want to run multiple servers for your Discord community or your friends or family or whoever. Containers make it super easy to start new worlds and new servers, and you don't have to worry about them conflicting with each other. This way you can have a survival, creative, and hardcore Minecraft server without them interfering with each other. So putting your servers on containers solves all these problems. Containers start up and boot, they're very trimmed down and use minimum resources. Containers are self-contained, not to interfere with each other, and it's very easy to host multiples of the same game. Now that you know why I like containers, let's start making some. Let's first start off with Minecraft Java Edition, as I'm a PC kind of guy. Minecraft servers are the easiest to set up and probably use the least resources, as it can run on a normal Raspberry Pi 3. This simple line will spin up a default vanilla Minecraft server with no problems. But that's kind of boring. So let's add some more environments to our stack. Here's the stack I like to use. Make sure to change your volume mounts to where you want. In my case, my Docker folder is in the root. I then have separate folders for each game server. We can change things like difficulty, max number of players, world size, all sorts of different things, even add mods and restrict the people that can access. I especially recommend turning on the whitelist users. This way, you don't get random people joining your server. All you have to do is log in through Buddy and add the users you want to whitelist. Now let's go over to Palworld. I probably should have done this video earlier, when Palworld was the most popular game for a few minutes. But better late than never. The Palworld Docker page says it requires 4 cores and over 16 gigs of RAM. But my current game server only has 16 gigs of RAM assigned. And I didn't see it raise very much, maybe like 5 to 10% with the server running and me running around playing the game. So take that as you will. Here's the stack that I use for my Palworld server. Just make sure to create your own server name and password, and you're good to go. This is a pretty vanilla version. If you want to spice things up, you can change the EXP rate, difficulty, capture rate, etc. Here's a full list of all the environmental options you can add to make those changes. The instructions on their website and Docker page are very straightforward and well documented, so I doubt you'll have any trouble spinning it up. Now let's go ahead and set up our Valheim server. This is the one I've personally been using the longest. It looks like this time, the Docker creators have done quite a bit of research and posted it about how much resources this Docker image will take. It requires about 2 cores and 4 to 8 gigs of RAM, which isn't too bad. This is another very easy container to spin up. You can even set up automatic backups for your world saves and tinker with mods, but I haven't really messed with that much. Now on to my newest server, Enshrouded. This is another heavy one, and it says that it requires 6 cores or 12 threads and over 16 gigs of RAM, but again, that might just be what the default server application requires, and proper research hasn't been done onto the real requirements for this image. Enshrouded is a newer game, and my friends and I kind of think it's a little bit better than Valheim, with a slightly different theme. I'm not sure if it's because it's new or just less known, but this container image has only been pulled a few thousand times, compared to Valheim, which is over 30 million, and Minecraft, which is almost at 400 million. Maybe because of that, the instructions and support options are pretty sparse, but the container spins up easily. Just run the stack and make sure that your machine has more than 31 gigs free, or else the server will error out and won't load. And start up the server, we're good to go, and you and your friends can explore the world. And finally, the most difficult container to get running, SpaceEngineers. SpaceEngineers truly gave me the most trouble, and that's probably why this image isn't very popular, with the most popular one being just over 50,000 polls, despite being a great game that has been out for a long time. There are a few extra steps that need to be taken to run this Docker container, and for the life of me, I couldn't find any tutorials on the internet. This led to a lot of trial and error. So hopefully this videos can help out others, and probably the future me. So to get this going, first we have to start up the SpaceEngineers dedicated server application, like normal on our desktop. Here we'll need to run the app as admin and let the app restart. Once it restarts, the Add Instance button will be available. We'll go ahead and create a name, and we'll need this name later, so go ahead and copy it and paste it into a notepad somewhere. Then we'll select our new instance and continue to server configuration. Here we can choose the game type, map, and any of the settings that we want to change. Make sure to create a secure password so that randoms don't join your server. Once you're done customizing everything, click Save and Start to launch the server. It'll build the world and save the files. After a minute, the server is up and running, but we don't want it just sitting on your desktop taking up space and resources, so we need to move it over to a Docker container. Go ahead and hit Stop to stop the server, and back to Instances to exit out of our world. Next, we'll have to navigate to where that instance is saved. To find it, it's located on your C drive under Program Data, which is a hidden file, and then in SpaceEngineers Dedicated. While we're here, we need to make the change that was the hardest for me to figure out. If we open up our instance, in the Save folder, we'll see the folder with our world name on it. This might be something like Red Ship or Moons or something that you made manually, but often it will put a date and timestamp afterward. If you have anything but that world's name, the Docker server will not work. So go ahead and delete those numbers, and we'll be good to go. I can't tell you how long it took me to figure this out. There was no notes, no documentation, and I couldn't find any tutorials showing me how to get this to work. All I was getting was pre-made world not found and session cannot start, which was extremely frustrating. After hours of troubleshooting, I found that this stupid file name was what caused all my troubles. But now I know, and now you do too. So again, delete those numbers and save this somewhere that your Docker server can connect to. My Ubuntu server already has my NAS mounted, so it's easiest if I just move this file over to my NAS. Next, let's start up the stack. Here's the one that I use. Make sure to change your public IP to a local IP that is not in use, and your instance name needs to be the exact same name as the instance you created using the SpaceEngineers dedicated server. Make sure to change your volume mounts to where you want. In my case, my Docker folder is in the root. I then have separate folders for each game server. Then we can deploy the stack, and if all goes right, our logs will look like this. It'll pause for a second on remote server listening, and then say session cannot be started, and restart. You can stop the container, and we'll move our instance file. For me, since I'm moving from my NAS, which is mounted in the MNT folder, I can use this command, but yours might look a little different. Sudo copy-r to copy a directory into another directory. It should only take a few seconds for that small world file to transfer. But once it does, we're good to go. Go back to your container, start it up again. In a few seconds, you'll get the glorious game ready message. And your friends and family should be able to connect to your server once and for all. The last thing you have to do is make sure to forward your ports on your modem so that people from the outside world can connect to your server. And that's that. Your servers are working side by side, and the only thing you really have to worry about is too many friends connecting and overloading your server hardware. I sure wish I had some friends. Thanks for watching until the end. And if you like this video and were able to get your own game server up and running, go ahead and hit that like and subscribe. It really helps me out. Also, feel free to leave comments down below with other ideas or projects you'd like to see me work on. Thanks again for watching. Bye!